allow B to lie anywhere on the vertical line, x equals to x naught. So this B will be here, anywhere. B is swinging, as shown in the diagram below. Now, the question goes further. The question goes further. Find the shape. Find. Let me write it again. Find the shape. Find the shape of the wire. Find the shape of the wire such that a bead, a bead placed on it at point A will slide under gravity to what? To B under the shortest possible time. Now, that is the question. Let's clean this. So what we want to do here is we want to find the shape of this wire such that a bead placed on it, that is, if you place a bead on this wire and the bead is allowed to roll under gravity along this curve. Now, according to the question, the bead will slide under gravity to be under the shortest possible time. Okay? Now, how do we go about this? That is the question now. How do we go about this? First of all, we need to find the speed of the particle. Let the speed of the particle given, let the speed of the particle be given as, v is equals to the s over the t. Why? Because since a particle is moving under gravity, it will require time and it requires speed. So now the velocity of the particle is this dot, the speed all over time. And if you can remember vividly from our equation of Newton of motion, you can remember one of the equations there is v squared is equals to u squared plus 2as, while our a is associated to gravity. So if the initial velocity here is 0, v squared will be equals to 2gs. Our s is standing as height. So now for us to know v here, v will be square root of 2g if s become h. So we have what? V is equals to square root of 2gh. So in this case now, this can be the same thing as the square root of 2g. Why? Y is standing as the vertical height. I hope you understand. Fine. Okay? So far, so good. We have assumed that the speed of the particle should be what? Root 2g y, where s is the length of the path. That's where s is the length of the path among the wire, and g is the acceleration due to gravity. I hope you are following. Okay. Now, what do we do? Since the element of the path length, recall, since the element of the path length since the element of the path length that is ds. You can remember that very well. Our ds is equal to, since the element of the path length, can we see that? Okay, will be equals to, remember, dx squared plus dy all squared. No, now the square root of this. Okay, and which eventually give us, which we are already familiar with, as 1 plus y prime squared raised to half. Please, are we following? Can we see this clearly? Okay, so that is the what? Ds. That's it. We have established this before. That is the element of the path length. Okay, now we have already gotten that before. It's like arc length. You know, it's a curve. So the total element of the path length is just that. All right. Now, the total time taken to travel to the time is given by the total time taken. The total time taken. Now, we need to find the total time taken. The total time taken to travel, you know, to make that journey along is a bit traveling from point A to what? To B, to travel along the line, x is equal to x naught. You know, it actually started from the origin. Okay, and it's traveling in line with, it's traveling along that wire. It will get to x is equals to x naught. Now, what is the total distance travel from here? From here, if you cross multiply, v dt will be equals to ds. Don't worry, don't forget we are looking for dt. Dt will be equals to what? ds over v. If you divide both sides by v, how that is taken. So now, if you want to get t here, you have to what? You have to integrate this particular value. And so integrating that value, you know, will give you what? Finding the integral of the two sides, you have integral of dt is equal to the integral of ds all over v. I hope we are following there. Good. So which is equal to 1 all over what? 1 over 2 root 2g. 2 root 2g. And what is your ds already? You already don't know what our ds is. Okay. Our ds is what? Let me write it clearly here. So this is going to be integral over this, and ds is got 1 plus y prime squared raised to half ds. I hope you are following. If you are not following, please let me know there. Okay, and all over this one, all over root y from here. If you check, okay, you know we said ds over v. We get dt is equals to, from here, dt is equals to ds over v. Okay, so if you make dt, solve the formula from here, you get this. Now integrating the two sides, you know, the integral of dt equals to integral of the whole of this. Okay, and that means we already know what v stands for. These are v. V is equals to root 2gy. You understand now? Okay. Now, since from here now, v is now what? It's now a denominator, root 2gy here. Okay. And ds itself is what? Is 1 plus y prime squared raised by half with dz. So you might decide not to put 1 here if you like. And at the same time, you can still put it. It's the same thing. Okay. So now, and don't forget that we have our x will be equal to s from 0 to x equals to x naught. Because we are moving from origin, we have to integrate from origin to when x is equals to what? X is equals to 0. Now, since the integrand does not contain x explicitly, we use what? Now we write this. Since the integrand does not contain x, that is what is by integrand, this value doesn't contain x. So since the integrand does not contain x explicitly, that is, it is independent of x, then we use what? Beltramian identity. We use Beltramian identity, which in other words we call this. You see what we use then we use f minus, that is the functional y prime df dy prime is equals to 0. Okay, so we're going to use that. That is the identity we are going to use. And if having integrated that, you get constant. So yes, it's going to be constant. It's going to be constant. So now that means that f is equal to I hope you are following, the square root of 1 plus y prime squared all over the square root of y, or the square root of y, or the square root of y. So which invariably means you are wondering where did I get this? Fine. Obviously this is Beltrami's identity. Okay. Now our integral here, 1 over 2 root 2g is a constant. You can bring it out. Okay. Our integral functional is the whole of this. That's what I mean. The whole of this. Our integral functional. Okay. So 1 over root 2g is a constant because g is a constant, accelerated gravity. So it's not part of the integral. That is what our f stands for here. So which we can write this one as what? You can say by the time this one comes up here, it's already raised by minus half here. So when it comes up, it becomes what? You have y into 1 plus y prime squared, 1 prime squared, then raised by what? Raised by half. Everything is raised by half. Dx, which is equals what? Which is equals to k from this constant. Okay. Now, having done that, what next? Let's look at what next now. Let's clean the board. Let's clean the board and look at what next. Okay. You have to clean the board and look at what's next. Let's look at what next. You just have to take it, a step after the other. Have to take it a step after the other. No, so let's change the marker. Let's change the marker. Okay. Now, the next thing is let's square both sides. Let's square both sides and see how it's going to look like. Squaring both sides. Squaring both sides. Let's square both sides here. When saying square this, we have what? We're going to have y into 1 plus y prime squared. Everything is per half. Then times 2 is equals to k squared. So this we cancel this. So we have we are going to have y into 1 plus y prime squared. Okay, is equals to k squared. So which implies, let's expand, y plus y prime squared is equals to k squared. Please, are we following here? Okay, are we following, please? If you are at a loss, let us know, please. Okay. I hope nothing else. No, we have made a mistake. Y is being omitted there. Yes. From this expansion, y prime squared. In this expansion. Okay. So we can write this as this imply y plus y dy dx, is squared is equals to k squared. Please, are we following? Okay, that is this. Now, so what's next here? What can we do? Logically here, we can try to extract, by making this particular dy dx is subject to the formula. Okay, so we can now say that y dy dx all squared, beautiful, can be equals to k squared minus y. Yes. So dividing both sides by what? By y. So when you divide both sides, dividing both sides by y gives dy dx all squared, good, is equals to k squared minus y all over y. Yes. So now, how do we get our dy dx? Finding the square root of both sides. Finding the square root of both sides now gives dy dx is equal to the square root of what? K squared minus y all over y. I hope you are following. Is that understood? Is that understood? K squared what? K squared minus y all over y. Okay? Now, let's do something. Let's logically do some things here now. So now suppose that you have to take it. That's why I'm taking my time to look at workings because I don't want to run into trouble here. Okay? I don't want to run into trouble. So we can say that let a be equals to k squared. Yes, and so that we have what? So that we want to introduce another variable to represent that k squared. So that we have dy is equal to the square root of a minus y all over y dx. Good. Yes. Okay. Now with this, we have to what? We have to collect like terms. We have to find a way of making sure that the y is where y should be. Okay? So if you multiply both sides by root y over a minus y, you know how what? Dy root y all over root a minus y is equals to dx. Does that make sense? Does that make sense to us? Good. Yes, I think that is sensible. Now we can't, because we want to what? You know, our target here is to integrate. Before you can integrate, we have to reduce this particular parameter. Now putting y is equal to a sine square theta. Yes, we want to reduce this parameter. Putting y is equals to a sine square theta. How? Fine. We now have the y to the square root of a sine square theta all over the square root of what? A minus, because y is a sine square theta. Now, which is equals to what? Dx. Good. Is equals to dx. So, this implies the y root a sine square theta all over a into 1 minus sine square theta, because a is common there. Okay, is equals to what? Dx. Okay, are we following? Good. Now we can say that the y into a here will cancel a here. The square root of sine square. I hope we are following. Sine square theta all over 1 minus cos square. Sine square theta is what? Cos square theta. This is equals to dx. Okay, which implies the square root of sine square theta is what? Sine theta all over the square root of cos square theta is what? Cos theta equals to dx. How we get that? Are you sure we get that? Good. So let's continue. Now this implies that the y tan theta equals to dx, because sine theta over cos theta is equal to what? Is equal to what? Is equal to tan theta. Please, I hope we are getting that. Beautiful. Are you sure we are getting this? All right. Beautiful. Very, very beautiful. Now, the integral now, from this now, we could actually integrate with respect to theta. We could integrate with respect to theta. Okay? So let's integrate with respect to theta. Now, recall, we have gotten this now. The whole of that, what do you call it? The square root has given us theta, tan theta rather. So recall, we said y is equals to a sine square theta. Remember that? So now that means that the y dx now, the y dx now, or the y d theta, sorry about that. The y d theta, not the x, will be equals to, this is like a function of function. So this only means like a sine theta all square. So you bring 2 out, you have 2a, good. Then you differentiate sine theta, you get what cos theta, fine. You now remove 1 from sine theta. And from this exponent, you have sine theta. So which implies, good, the y is equal to 2a cos theta sine theta d theta. Okay? Now, and you are multiplying it by what? Down, because you have dy. So you get it down. Now our dy is what you have gotten as this. Multiplying by tan theta that we got before. So times tan theta. And what is tan theta? Sine theta all over cos theta. Everything is equals to the x. Everything equals to the x. Okay? I hope you get what I say, because you know how we got this. Good. Our dy from this, from our assumption, our dy will be equals to this when we differentiate with respect to theta. Now, when I cross multiply, I have dy is equals to this d theta. Then times our tan theta, which is sin theta over cos theta. So it's equals to that. So this we cancel this. So now have the y is equal to 2a what sine square theta, the theta is equals to dx. Yes, is equals to dx. Okay, before we can integrate, we have to solve this problem first. Now we need to do some calculations there. Recall. It's called sine square theta plus cos square theta is equals to 1. And that implies that cos square theta is equals to 1 minus. Sorry, we want to replace sine square theta. Sine square theta is equals to 1 minus cos square theta. Fine. And don't forget also, cos 2 theta is, is cos square theta minus sine square theta. Fine. So now we want to relate this with this. So this one comes here now. Okay. To get cos square theta now, this is very simple. It's the trigonometry that you are familiar with. I want to replace this cos square theta. So that means I make cos square theta, sorry, formula. So this one come here now, cos 2 theta plus, because this will be, it will be plus. I will together now, fine. Sine square theta equals to cos square theta. Okay, so now I'll plug this value inside this. Let me call this I, let me call this I. Now I expected to have known this before now. Okay, so now plugging it, have that implies sine square theta is now is equal to 1 minus. What is my cos square theta? I have what? I have cos 2 theta minus sine 2 theta. I'm sorry, minus sine square theta. The whole of this now is what I'm bringing in. Okay, so it's plus. So when you put it in brackets, they are plus. By the time you open them up, they become what? Minus. I'm very sure you must have known this one before. So now bring this sine square theta here. You have what? Sine square theta plus cos square theta is equal to 1 minus cos 2 theta. So which means 2 sine square theta. Why am I making a mistake? You are bringing this one here. This one comes here. It is negative. When it comes here, it becomes positive. So please be careful of making unnecessary mistakes. Okay? So this will be 2 sine square theta equals to 1 minus cos 2 theta. So now sine square theta will be 1 minus cos 2 theta all over 2. So that's where I'm going. So I want to replace this sine square theta by what I've gotten there. So I've got what? Let me write somewhere. The y is equals to 2a sine square theta d theta equals to dx. Okay, I will use it later. Okay, now with that, now I will now replacing. Therefore, I have the y is equals to 2a instead of sine square theta. And I have what? 1 minus cos 2 theta all over 2 d theta is equals to, I hope you understand now, is equals to dx. So that implies that integrating the y is same thing as saying integrating, this cancels this, a into 1 minus cos 2 theta d theta, which is what? Integral of dx. Yes. Don't be confused. Don't be confused. Now, I can extract this one out and have it at a d theta minus, minus what? Minus a cos 2 theta d theta. If I like, I might split it. Yes. You know, I can expand and split like this. I hope you understand what I'm doing. I can split, you know, we are opening with a. A times 1 is a d theta. Then minus cos 2 theta times a minus integral of a cos 2 theta d theta equals to dx. I hope you are following. Just take your time. It's not difficult at all. It's not difficult at all. So, this one is what? If you integrate a, you know, a is a constant, can be brought out. You have a theta, good, minus, now, this is another constant a. Then, now, if you want to integrate cos 2 theta, don't get it twisted. Integrating 2 theta itself is just like you are differentiating 2 theta. You get 2. So, put half there. Then, you know, when you integrate cos 2 theta, you are going to get, that's when you integrate cos theta, you get sine theta. So, but since it's 2 theta, you have sine 2 theta equals to x plus c, because when you integrate, you are integrating everything. Let's put in without it. Okay, I hope that is clear, please. How we understand? So we can now write as what? We can now write as, a theta minus a all over 2 sine 2 theta is equals to x plus c. Okay, is equals to x plus c. Now we can do some calculations here. We can do some calculations here. What do we mean here? We can do some calculations here. How? Good. Now recall that. You can recall that this one could be written as, you know, since, you know, sine 2 theta is 2 sine theta cos theta. I hope that is clear. Good. Good. Now, this one, okay, we can change it to a all over 2 theta minus, yes, when we factor out a all over 2 theta, you know, minus what? This will be 2 theta minus sine 2 theta. Okay, is equals to x plus c. Okay, I've not done anything special there. I'm not even using this again. I will tell you what I did there. I'll tell you what I did there. What I did there is just, I want to rewrite this in another form, in another way, so that I will simplify it in a very, okay. You know, if I multiply 2 times 2 is theta, so that will be a theta. Then this one a over 2, I just try to factor out a over 2, but that's what I did. So which invariably means my x now, my x can be what? A all over 2 theta minus sine 2 theta plus c. You'll be wondering, wow, should minus? No, this is the constant. If I bring x, if I make x a formula, okay, if I make x a formula now, I will have all of this, you know, x, then minus c, and there's no sense in having minus c. It should be plus c because it's a constant of integration. Are we following? Good. Now, having written this, having done this, we are still going, we are still going. We are still going. We are very close to the answer. Thus. So can you see this? Thus, we have the parametric equation. We have the parametric equation. We have the parametric equation from what we get there now. X is equal to b psi minus sine phi plus c. From what we get there, from that equation that we got now, you see, I'm going to assume then my y is, you know, my y is a sine square theta. So sine square theta. So b into 1 minus, should it be 1? B into 1 minus, yes, I think it should be 1. 1 minus cos phi. You can check that too. You can check, it's not theta, it's cos phi. Okay, where b is equals to a all over 2 from what we just get now, and phi is equals to 2 theta. From what we have just gotten, that is it. This define is cycloid. This particular values we are getting define is cycloid. And what is a cycloid? A cycloid is a is a curve that is drawn from the circumference of a circle from a point, which which is drawn to actually define the path of that particular circumference with respect to the tangent of the curve. Now, and when you have a bead, a bead can be, you can release a bead that will, a bead will dive down, a bead will glide through under gravity through the curve of a cycloid at a constant time. At a constant time, because you usually have a shortest descent. A cycloid has elements that are, when an element like a bead is asked to roll down, from one point to another under the influence of gravity on the cycloid curve, it's going to arrive at the bottom part of the cycloid at what? At a constant time. It's going to arrive at a constant time. So this defines a cycloid with radius b, with radius b along x-axis, along x-axis. Now, to determine the value, let's determine the constant, constant b and c. Want to determine constant b and c, we observe that, since the curve passes through what? Through the origin. Since the curve passes through the origin, c is equal to 0. Yes, that is the truth. Now, c is equal to 0 because there is no y or x intercept there. Once the curve passes through the origin, it doesn't have an intercept. So c is equal to 0. And with that, since y of x naught is arbitrary, that is, the upper end points can be, let's say that endpoint can lie anywhere. The upper endpoint can lie anywhere. Okay, that is on the curve. On the curve x is equal to x naught. The upper endpoint can lie on the curve x is equal to x naught. Then we have, if the upper end curve can lie, then we use one of the Beltrami's inequalities, or the Beltrami's equation rather. Then we have del f del y prime, yes, restricted to x equals to x naught, which is the destination point, which is the end point at which the bead stops. So now, how do we go about this? Can we now recall, since what is our f? Do we still remember what our f is? I think our f is the square root of let's check what we got from our f. I think what was our f, so that we're able to do that together. Let's try to look at that. Our f is 1 plus y prime squared all over root y. Okay, so that's our f. Good. Now we want to differentiate partially with respect to, y is a constant here. So we can write this as 1 all over root y, then square root of 1 plus y squared raised to the power half. That's what we want to do now. We want to differentiate this f with respect to. So now that means, I think I will have to clean this again. Let me clean this. So that means that I will have, I'm differentiating with respect to y prime. So this is a constant. I will still have 1 over root y is a constant. Okay. Now, differentiating this, we have times 1 over 2. Now differentiate, just like function of function. 2 y prime, good. Then multiply by 1 plus y prime squared. 1 plus 1 plus y prime squared. Sorry about that. 1 plus y prime squared raised power minus half. So this will cancel this out. So let's write. Let's see what it's going to give us. So we are going to have this 1 over. I'm going to have y prime rather, all over root y into 1 plus y prime squared raised by minus half. Okay, if that means we can bring down one down, have what? Y prime all over root y. Then this one also will be what? 1 plus y prime squared. 1 plus 1 prime squared. Y plus 1 prime squared raised by half. What does that mean? It means that they have the y prime at x equals to x naught cannot be written as y prime all over root y root 1 plus y prime squared. Yes. Yes. If we like, we can combine them together by saying, we can write y prime all over, root y into 1 plus y prime all squared. No? That's square will be on y prime. That square will be on y prime. Okay? That square will be on y prime. So that is what we are going to get there. That's what that. So when we restrict it to x equals to x naught, the constant will be 0. When we restrict to x equals to x naught, constant will be equals to 0. So that implies y prime is equals to 0 at x is equals to x naught. From that, y prime equals to 0. Thus, the tangent, conclusion now, the tangent, so we conclude that thus the tangent to the cycloid, that is the shape of the curve is cycloid. To this curve cycloid at B, that the endpoint must be parallel to the x-axis. Must be parallel to the x-axis. And in that case, our theta is going to be pi. So multiplying pi by b, this gives what? This requires that, or this consequently gives, because theta is going to be what? Our theta will be what? Pi multiplied by b. This will pi is equals to theta equals to pi multiplied by b, which is equals to our x naught. So the equation of the tangent to the cycloid at that point B, which must be parallel to the x-axis, with what? Pi b is equals to x naught. So in this case, we have come to the end of this particular question. The question looks very long, and but I want you to take your time to understand how each step was taken. So if you are joining this particular channel for the first time, don't hesitate to subscribe. After subscribing, click the notification bell so that each time I upload a video, you'll be immediately notified. And if you have been enjoying this video before, well, I don't expect you not to share, comment, and like. Please like this video, share with your colleagues. God bless you. Bye.